we're looking at gravity, and I want to take into account a case where you throw a ball up in the air. So first of all, you start with the ball in your hand and you're about to throw it in the air. When it first leaves your hand, it is going its very fastest velocity. Think of it as maximum kinetic. Kinetic means motion. It's maximum energy here. Now, as you throw it, it starts slowing down because of gravity. As it rises, it slows down. It's still going in the up direction, but with negative gravity accelerating it, it slows down. At its highest point, for a split second, it actually stops. It's all potential energy and no kinetic. Potential because all of a sudden it is going to fall back down, so it has the potential, and it has no kinetic because it stops moving. Its instantaneous velocity is 0. So at this point, its velocity is 0. Coming down, it's moving with an increasing velocity. It starts speeding up. It's losing its potential energy as it gains its kinetic energy. A ball moving down faster and faster still means gravity is a negative acceleration. It's still negatively accelerating it this way. The negative means the direction. Back to the original height, it started from all of the potential is back to kinetic, so it's moving at its very fastest speed. It is moving just as much down as it originally was when you threw it. So if you threw it at 3 meters per second, it's going to come down at negative 3 meters per second. Okay, so a good diagram to think of how gravity, acceleration due to gravity, affects throwing a ball. We're going to do a series of 5 questions, one at a time. For the next questions, we're always going to assume that we took a ball and we threw it at 16.3 meters per second. First of all, we want to know its velocity after 8 seconds. Okay, 0.8 seconds. So we have an initial velocity of an initial velocity of 16.3 meters per second. We have a time of 0.8 seconds. We want to know our final. And we know our acceleration due to gravity. And it's going to be negative 9.81 meters per second squared. That's what we learned about in this last section. Okay, the formula I'm going to use is V final equals V initial plus acceleration times time. Putting in the values that I know, V initial was 16.3 meters per second plus acceleration negative 9.81 meters per second squared times my time of 0.8 seconds. So I'm running out of space. V final. Okay, this is going to give me meters per second plus meters divided by second squared times seconds. It's going to be in meters per second. Now what I have to do is I have to actually do the math. So 16.3 plus negative 9.8 times 0.8, and I get 8.452. So make sure that you take a second to use your calculator that you can get that number as well. Significant digits. It looks like I can have 2 significant digits. I'm going to pretend this one more. 2 significant digits. The final is 8.5 meters per second. Notice that's positive. Right, we're still going upwards. That ball is still going upwards.